Hi, welcome back. So let's try and solve the next hard level 2 questions. I hope you have gone to the video. Let's just get going. So I meant gone to the last video. So I'm just take off my space. So we're going to just solve this next question now. I'm just choosing another color. A car is being driven along a road of 25 meters per second. So this is the starting velocity. When the driver suddenly notices there's a fallen tree blocking the road 65 meters ahead. So this is my car, 65 meters ahead, there's a tree. So that's the tree. That means the driver has to stop, isn't it? So the final speed has to be 0, yeah? And the distance is 65 meters. So he has to stop in 65 meters. So given the acceleration is 5, how far in front of the tree does the car comes to rest? So does he need 65 meters, or he needs more than that, or he needs less than that? That's the kind of question here. So we're going to use v square equals u square plus 2as. The final speed is 0, u is 25, so square, as I told you yesterday, last video, you need to first write some calculation and then plug it in the calculators if the calculator is allowed in your board. Then 2, acceleration is because it's a retardation, we're going to write -5 and then calculate s. So this is going to be 625 minus 10s equals 0. Rearranging, I get 10s equals 625. So I get S as 62.5 meters. Now, the question does not ask you how far it travels, how far in front of the tree it stops. So how far ahead? It is 65. So it stops at, take away, 2.5 meters ahead of the tree. Okay. Now see, these are the kind of questions which teaches you how to apply the equations. They are not specific to an exam board, because exam boards would be checking your knowledge in this particular area and also in other contexts. So like connecting the equation of motion with forces, friction, or circular motion, anything like that. So these are just equation of motion to get you a hang of these equations. All right, let's continue. A particle moves with uniform acceleration, so that's the q. I can apply my equation. My acceleration 0.5 in a horizontal line ABC. So now it's asking A, B, C. That's a horizontal line. The speed at C is 80, so the speed here is 80 meters a second, and the time taken from A to B and B to C is, so this time is 40 seconds and this time is 30 seconds. Okay, now they're asking you what's the speed here, but the acceleration is uniform throughout. So if it has got a velocity of 80 meters per second with an acceleration of 0.5 meters per second square for 30 seconds, what would be the speed here? So if I know the speed here, that would act like my final speed for this part, and then I can use, so basically what I'm doing here is I have to apply v equals u plus 80 2 times. First, I'm applying from B to C. So my final speed at C is 80. My starting speed at B, I don't know. Acceleration is 0.5 and time is 30 seconds because we are applying it from B to C. All right, so I'm just going to simplify. 80 equals U plus 536, yeah, 660. That's right. No, sorry, this is 15. Now then, you just take 15 that side. That gives me 80 minus 15 is 65 meters per second. So that speed is now at B. So this is 65 meters per second at this B. Now, because we want speed at A, we're going to apply the same equation, but now we're going to apply from A to B. So now same v equals to u plus 80, just using another color to help you differentiate from A to B. So what's my speed at B? That is 65. I don't know speed at A. That will be my starting speed. A. So that's why drawing the diagram helps, because sometimes it confuses you. What's V? What's U? What's A? What's T? Just draw a line diagram and then we can just work it out. Acceleration is same because it's constant. And the time from A to B is 40 seconds. So this gives me 65 equals u plus 20, giving you u as 45 meters per second at A. So we got the speed at A, done. Now it's asking you what's the distance BC, this distance. So we know the final speed at this C, we know the starting speed at B, we know the acceleration 0.5, and we can just calculate S. So I'm going to use another color. I'm going to use V squared equals U squared plus 2AS. So that's a nice color. So V is 80 squared equals 65 squared plus 2 times my A is 0.5 times S, because I need S. Okay, so now this would need a calculator, so I would just leave you to solve this and get S. Okay, so that would be the simple level 2 kind of questions. Now we're going to just move on to little tough questions in applying this equation. So I have the level 3 questions here. Okay, if you think that you still are not very happy with the kind of questions you have solved, or are you not very happy with the understanding of this equation, so watch the previous video, entire thing re-revise to level 2 questions all over again, and the easier questions that I did yesterday, and then we can just move on to level 3. If you've done all that, let's continue. Okay, so a train travels along a straight piece of track. So I'm going to just do my favorite thing, draw the diagram again, A to B, because it's a straight piece of track. The train starts from rest at A, so my starting speed is 0. Train starts from rest at A and accelerate until it reaches 20 meters per second. Okay, so it accelerates 1.25 meters per second squared till the final speed is 20 meters per second. So we don't know the time for which it does, so I'm going to just go ahead and calculate that. So V equals to U plus AT. So V is 20, U is 0, acceleration is 1.25 t. Calculating 20 divided by 1.25 will give me the time, which is 125, 250. So just calculating that. So that comes out to be around 16. So my time is then 16 seconds. Okay, 16 seconds. So got the time. Okay, so it's accelerating for 16 seconds, not the entire journey all the way up to B. Okay, so this is kind of question, I think it's trying to change the acceleration. So before we go ahead with this, there is the easier way to solve such kind of questions is by drawing the graph, but I'm going to tell that a little later. Let's just solve this first with equations first. It then travels at this speed for a distance of 1560 meters. That means, so this is the first part of the journey. I'm going to take another color. Then the second part of the journey, acceleration is 0 and it travels at constant speed, of 20 meters per second for a distance of 50-60 meters for 1560 meters. Okay, so that means now, can I calculate the time? I can. I'm just going to calculate the time it requires. So now because acceleration is 0, So it's now just simple, distance is equals to speed times time. Yeah. So I'm just going to calculate time as dividing distance by speed, which gives me 2 7s are 14, 2 8 16, 78 seconds. So it was moving at 0 acceleration for 78 seconds. Now, and then decelerates at 2 meters per second squared to come to rest at B. Now, this is the third part of the journey. Now, what is it doing? It is decelerating. Okay, so now decelerating. So the final speed is 0. The starting speed is 20 meters per second. And it comes to rest, okay, at B. So the final journey, he stops at B. So the final speed is also 0. So I'm going to just draw it here. So maybe part, because the first part it was accelerating for 16 seconds. Can we calculate the distance? So just, just writing the first part, the second part, and the third part. Now we're calculating the distance it traveled in the first part. So I'm just going to use v square equals u square plus 2as. Final speed is 20 squared 0 plus 2 times 1.25 times s. The 400 equals, this is 2.5s. So 400 divided by 2.5 is the distance, which is 25. How much? Okay, so dividing, I'm just going to use a calculator. 4,000 divided by 25, which will be, okay, 160. That was easy. 160 meters. So it has traveled 160 meters here and then 1560 meters here. Now we have to, because I think it's asking us to calculate the total distance from A to B. So this, we need the final distance here. Okay, now for this part, A is -2. See, decelerates at -2. So we're going to use same equation. So now if you don't do the diagram, or you do these kind of partitions the way I've done, first part, second part, third part, there is a lot of confusion because you're using the same equations. And because you're using the same equations, there's, oh my god, there's so high chances that you'll get confused. Which is V, which is U? Or the best method is to draw the graph, but that I'll teach you later. I've not talked about the graph yet, so let's not go there. So V is 0, stopping finally, moving at 20 times 2 times S. So this is 400, and this is 4S. So S is 100 meters. So it travels further 100 meters to come to stop. So this is 100. Okay. So now, I hope I've done it correct. 400, yeah, that's right. So the total distance it takes to travel from A to B would be, how much do we calculate it for S? 160 plus 1560 plus 100. So 160 plus 1560 plus 100. That is 1500, 1600, 1700, 1760, 1820. So 1820 meters. Total time for the journey. So we've already got the time here, 16 seconds. Plus we got the time here, 78 seconds. Plus, let's calculate the time in the last leg of the journey. Here, B, same, B equals to U plus 80, final 0. This is 20 minus 2 times T. Now, some of you would be very good at solving these kind of questions. It is sometimes, it just depends on how many questions you've solved earlier in your life, which requires multiple layering. So it's not about you, it's about the questions you've done in the past. If you're not able to solve it like in a straight go, it sounds confusing. Pause, work it through. Pause, work it through. And there's no reason why you can't solve it. Okay? So this is 88 and 98 and 6 is 104 seconds. Now for the average speed of the journey, average speed is like if there is no acceleration, if you would have traveled at one constant speed for the entire distance of 1820 meters, one constant speed, 404 seconds, what would that speed be? So that speed is called average speed. So without accelerating or decelerating, if you would have traveled with one constant speed, the train would have traveled with one constant speed, what would be that constant speed? So that's what average speed is. That you just calculate using total distance divided by total time, which is 1820 divided by 104. I'm going to just work it through my calculator. So this is 1820. I think you can't see my calculator. I'm just using another window here. 4 equals, which is 17.5. So if you would have traveled at a constant speed of 17.45 meters per second, the train would have traveled at 17.5 meters per second. It would have covered the entire distance in that 104 seconds, right? So that's kind of the most difficult question which you can get from using only the equation of motions for uniform acceleration. Now what I wanted to go through is to understand drawing the graph, so we can understand and solve these kinds of level 3 questions easily. So let's just start solving the graphs. Just give me a second, let me just attach the PowerPoint to it. Okay, just give me a second, let me just attach. Just give me a second, alright, just trying to figure out how to do that. Brilliant. You can see this? I think yes. Okay, so now the graphs. So basically we have the graphs between distance and time, velocity and time, acceleration and time. So as with everything else, if you're doing physics, you must be seeing graphs everywhere in the questions. So even you have graphs in this, but graphs are there to make your life easier, not difficult. So let's understand them. So these are the first, oh my god, what's that? So we're going to just try and go through some basic simple distance time graphs. Okay, so the first one, let's just understand what does it say. So because in equal intervals of time, the body is covering equal distances, that simply means that this graph shows that the speed is constant. Okay, the speed is not changing. So because the speed is constant, what is the acceleration then? The acceleration is, yes, you're right, acceleration is 0. Okay, and right here, oops, acceleration is 0. Okay, next one. What does this shows? As your time is increasing, is the position of the particle changing? Is at the same distance at different times. So what does it show? This shows the speed is 0. So there's a difference between constant speed and 0 speed. Constant speed is, it is still there, still moving, only the speed is not changing, right? Now, still in equal intervals of time, it is covering equal distances. What does that show? Still the speed is constant, but what is the difference between speed is constant, so what's the acceleration? Perfect, acceleration is 0. Okay, what's the difference between graph A? You can always pause and rewind my video to see what I've written. Just don't want to have a mess on the screen when I explain you a new concept. Okay, so what's the difference between the graph A and graph C? pause. See, whenever I ask a question, always pause. Don't wait for my answer. You answer it and then play and check if you were right. And most of the time you will be right. Well done. Okay, so what is it? A and C. What do you think? This shows that it has a higher speed. Okay, now if you talk about the maths, what part of this graph, okay, let me just tell you that the gradient of the C is higher than the gradient of A. So speed, how do you get the speed? Speed is the gradient of speed time graph. Okay, now, oh sorry, no, I'm thinking speed time, that's why I'm not. Gradient of distance time graph. Okay, so distance time graph. So if the gradient is not changing, as in A and C, the gradient is not changing. So because the gradient is not changing, the speed is not changing. So but whoever has the higher gradient, he'll have the higher speed. Okay, let's just see now the D. What was the gradient in B? 0. So no gradient, no speed. So speed is 0. Okay, now let's see the D. Now this is a changing gradient graph, but what's happening to the gradient? Is the gradient increasing or is it decreasing? Okay, some of you who already have maths, I think you can figure out what I'm trying to say here. So you see here, so the graph is increasing gradient, increasing slope. So because it's an increasing gradient graph, the speed is increasing. This shows an increasing speed. So if the speed is increasing, does it have acceleration? Yes. So this means it is accelerating. Okay. So the only thing that you need to know from here, now you need to know many things. The only thing you need to remember offhandedly is like if the gradient of a speed distance time graph gives you speed. Okay. All right, let's go to the next one. VT graphs, velocity time graphs or speed time graphs. Let's just see, analyze. If I ask you a question, pause and try to answer it yourself. So as the time is progressing, increasing, is the value of velocity or speed changing? It has the same velocity all throughout. So what does that mean? That means speed is constant. And when you have a constant speed, what's the acceleration? What is it? You're right, 0. Now, is the speed increasing? With increasing time, is the speed increasing? As you can see, different values of time will give you different values of speed. So is the speed or velocity increasing uniformly? Is it increasing by equal amounts in equal intervals of time? That's right. So that means acceleration is constant. And how do you get acceleration? And acceleration is gradient of speed time graph. Okay, you can just see this. If I make a triangle here, so the gradient is y, change in y over change in x. So change in y, this gives change in velocity, isn't it? And the change in x gives you change in time. Say, what is change in velocity over change in time? Change in velocity divided by change in time is nothing but acceleration. So the gradient gives you the acceleration. Now the next thing is this one. So as you can see again in this graph, the gradient is increasing. It's an increasing gradient graph. That means the acceleration is increasing. Because acceleration is increasing, the acceleration is not constant. So if acceleration is not constant, could you use Suvat's or the equation of motions for this kind of graph? No, you can't, because acceleration is increasing, it's not constant. Okay, now there's one more thing. There are some kind of exam, not almost all exam boards would always ask you a question, uh, how to calculate distance traveled from a velocity time graph. Okay, so because you don't need to know this, I'm not telling you how to get to this, although it's not very difficult. But there's already so many things to know. Why unnecessarily give you many things which you don't need? So just know that the area under the VT graph, okay, so this area here, this area gives the distance traveled. So the gradient gives acceleration, area gives the distance traveled. All right, okay. Let's understand this graph. Pause the video, try to figure out yourself what kind of graph these are. If yes, you've done that, let's just see. So acceleration time. So as the time is progressing, it has same values of acceleration all throughout. So what does this say? So this says acceleration is constant, not changing. Can you use equation of motion here? Yes, you can. Here. Acceleration as the time progresses, what's happening to acceleration? Is it increasing? Yes, it is increasing, right? So increasing acceleration. So acceleration is uniformly increasing because it is increasing, uniformly increasing acceleration because it is increasing by equal amounts every time. Now here you can see it's increasing very slowly and then a steep increase. For a small duration of time, the acceleration increases very steeply. So this is non-uniform increase of acceleration. That's it. So basically, when you see the graph, you should be able to understand what a given graph shows or tells you, and then you analyze the graph and then you try to do the questions. Some of the questions would want you to do the graph, make the graph or draw the graph, and some of the questions would ask you to analyze the graph. Okay, let's just do some questions on that. Actually, let's just go back to that level 3 question that we did, and let's try and do that using the graph. Okay, let's see if this one allows me to go there. Oh yes, here we are. Let's just solve this question. Okay, so I'm just going to clear this so that we can have a clear, okay, come on. Okay, so now because in this question it is asking us again the same thing, what is, okay, I'm just going to draw the graph. Okay, let's just get going here. A train travels along a straight piece of track between two stations A and B. So what I'm going to draw here is I'm going to draw what is changing throughout. My acceleration is changing, my speed is changing. So whenever you have a changing speed question, acceleration questions, because these are for the first bit of time, the first leg of its journey, the acceleration is 1.25. The second leg of his journey, the acceleration is 0 because he's moving at a constant speed. The third leg of his journey is decelerating, so acceleration is -2. So this is a changing acceleration question. So whenever you have a changing acceleration question, draw a VT graph. Okay, let's just see. I'll be solving exam specific questions I'll be solving at Excel, AQA, or ITJ, or NEET. We'll just solve exam specific questions in the coming videos. Right now, just focus on concept. Okay, let's just see. Okay, so this is my time in seconds, and then I have velocity here in meters per second. Okay, so I'm just marking the time 0. Of course, you do not have to be very precise in making this graph, because of course you are not drawing the graph for getting the marks on the graph. It's just to see what kind of motion is happening here. And then for 78 seconds, and the last one was 10 seconds. So my just 78 is all the way here, and then 10 seconds. So 10 seconds. Okay, so from 0 to 18 the speed is increasing, reaching a maximum value of 20, isn't it? Yeah, so this is 20 meters per second. After that, it moves at a constant speed till 78 seconds, and then it decelerates and stops in 10 seconds. So now see, it becomes so easy when you draw the graph. And now you can figure out the total distance traveled by calculating these 3 areas: this area, this area, and this area. So the graph are helpful in visualizing what's happening to my different circuit elements. Like for example, my acceleration is the gradient of VT graph. So see the gradient here and see the gradient here. It has a steep gradient. Obviously, it has larger acceleration or retardation, so steep gradient. Because it's positive gradient, it should be acceleration. Negative gradient, it should be retardation. Constant, 0 gradient, it should be constant speed. So it's a beautiful way to analyze the different question elements from the graph. Next video, we will solve some exam specific questions on this part of mechanics. This is kind of kinematics. We have not started the dynamics part of mechanics. Now, dynamics is where you study about forces, cause of motion. So this is motion, where we measure speed, velocity, acceleration, distance, displacement. The dynamics part is where we talk about the forces, resultant forces, acceleration. So we haven't started that yet. We're still on kinematics. So next video, I'll be solving some exam questions from different examples. Right, so for now, take care, keep revising, keep studying. See you all. Bye-bye.